All right, so in this video, I'm going to continue on the idea of magnetic force and charges moving through a magnetic field or a uniform magnetic field. So if I have a uniform field, so let me just draw one, right? We learned that we have this right-hand rule where we can determine the direction that a charge is moving as it flies, through this field. What is the direction of the force on that charge? So let's say that I have an electron up here entering this uniform field with some velocity v. Okay, and I shot that charge into this field. I want to know what is going to be the path of that. So just as a review, we're going to do our right-hand rule. So I got a plus here and I got a minus here. So my fingers are going to point in the direction of the magnetic field. My thumb points in the direction of the charge movement. And remember, the charge is in the middle of my hand, and so it's going to be either attracted to the top of my hand or my palm. So if I hold my hand like this, and I know it's pretty hard to see, but I'll hold it like that, I guess is the best way. You can see that the charge is flying into this field. My fingers are pointing in because of the X's for the magnetic field. And so because it's an electron, it's going to be attracted to the positive side of my hand. So as soon as it enters this field, it's going to be pulled in this direction. So as it flies into the field, you're initially, like right away, going to have a force vector that points in this direction. And if I have a velocity in this direction and a force in that direction, that's going to elicit some circular motion, right? And so the object is going to start to turn. And as it turns, so does my hand. So as it turns through, it's actually going to, the force is also going to turn. So this is going to have some circular arc to it of some radius r, okay? And if I was actually given the values, then I could equate this force right here, or force magnetic, and say that is what is, in this case, causing my centripetal force. And centripetal force is, I'll write that here, remember, is mv squared over r. So I would set FB equal to mv squared over r. And from the last video, I learned that the force magnetic is actually equal to Q times the velocity of the charge times the strength of the magnetic field. So I get that QVB, so Q being the charge of the electron, which we know, V times the strength of the magnetic field is equal to mv squared over r. And I'm not going to simplify it, but we can just see that relationship. So that's a common type question, looking at how these variables affect the arc of the radius, or figuring out velocity. Remember that quite often they will give us a charge like a proton or electron that we actually know the charge of it. Now in the next video, I'm actually going to go ahead and look at a concept of using both magnetic fields in conjunction with electric fields.